Hello everyone. Let's take a look at our next problem. Write down 3 digits and then write the number again next to itself. For example, 1, 2, 3, 1, 2, 3. Why is it divisible by 13? Okay, so the first thing that comes to mind is the easiest way to solve this question, or at least what I'm going to try when I have a question that specifically deals with digits and things in base 10, is to write down what it actually means to represent a number in base 10. So for example, starting with the number 123 and then writing that 3-digit number next to itself again, this is equal to 1 times 10 to the 5 plus 2 times 10 to the 4 plus 3 times 10 to the 3 plus 1 times 10 to the 2 plus 2 times 10 to the 1 plus 3 times 10 to the 0. This is simply what it means for a number to be represented in base 10. So the question says if we start with any 3-digit number, then the constructing it this way by repeating itself should be divisible by 13. So let's go ahead and write down. So A, B, and C are integers from, well, 1 to 9 or 0 to 9, I suppose. I don't know whether this divisible by 13 thing will hold if A is equal to 0. I suppose maybe as we go through this, we'll figure out whether that's true or not. But A, B, and C are numbers between 1 and 9. And B and C, I suppose, certainly can be 0. It's questionable whether A can be 0. So let's just write out exactly what this means. I'm using bad notation here, right? These are supposed to be. This is supposed to be a 6-digit number. This is not a product of A, B, C times A times B times C. But I think you probably get the idea of what I'm going for here. Anyway, what I'm left with is A times 10 to the 5 plus 10 squared plus B times 10 to the 4 plus 10 plus C times 10 to the 3 plus 1. And this is equal to, I can factor out some multiples of 10 from all this. And I end up with, you'll see there's a common factor everywhere here of 10 to the 3 plus 1. Okay, so I'm guessing that this number, 10 to the 3 plus 1, or 1001, I'm guessing that that's divisible by 13. I'm going to put myself on the spot here and see if I remember how to do long division. I even remember the symbol for long division. Excellent. Okay, so 13 doesn't go into 10. How many times does 13 go into 100? 7 times. 7 times 13 is 91. Oh my goodness, I'm putting everything in the wrong place here. And what am I left with? I'm left with 91. Oh, cool. So, yeah, 77 times 13 is 1001. All right, so if I continue down from here, I can write this. I have a product of this thing in terms of A, B, and C. And this number, 1001, that's equal to 13 times 77. And so that's why it doesn't matter what numbers you choose for A, B, and C. And in fact, you see now that if we allow A to be 0, it'll still work. But of course, you do need to have a 0 in this spot here. The way we've constructed this 6-digit number from the 3 digits A, B, and C will always have a factor of 13. Nice little problem. But the key here, anytime you're asked something that has to do with individual digits, in particular in base 10 or any base for that example, understanding what it really means to represent a number in base 10 often reduces the question to something about something else. In this case, something else to do with a common factor that the entire expression had. Thanks for listening.